Okay, this is a test I gave my Chem 131 class, which is equivalent to this class, a couple of years ago. More like 5 years ago. And it's a test on alkanes, alkenes, aromatics, and alcohols. So let's go through here and see what one of my tests look like. All right, start off with naming. So what do we have here as a base? That's right, there's a benzene there, there's an alcohol there. What is the benzene alcohol? What's its name? It's a special name. Phenol. So that automatically makes that carbon number 1. So we have 2-ethyl phenol. Yeah. It's got 2 carbons. Yeah, yeah. I copied this out of one of the PowerPoints. So, if this was a line drawing, it would look like that. Okay. So now we have a alcohol, and we need to name this puppy. So remember, the longest carbon backbone has to include the functional group. So if this is an alcohol, the longest chain has to include the OH group. So for sure, there's that. Okay, so that's 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7. So it looks like that's the longest chain. So we have a and that exists on carbon number 1. And we have 2 branches. We have a methyl group, carbon number 2, and 2, 3, 4, 5, and a T butyl group at carbon number 5. So it'll be 2-methyl 5-T butyl 1-nonol. So we've got the functional group there. And then we have 2 branches. Okay, what about this guy here? Now I gave everyone for this test 2 hours, just like I'm going to give you guys 2 hours also. So what we'll do is we'll take 2 hours down here, and then we'll go to lab afterwards. I also have the dry lab. Those people that have Tuesday lab, I've got your dry lab right here. So on the way out, just grab one. Okay, so what do we got here? We got 6-sided ring, cyclic compound, and it's an alkene. So it's going to be cyclohexene. Now, numbering. Okay, well, if we start numbering here, That'll give us the smallest number of methyl branches. If we start here, the numbers are going to be quite large. So this is the way will give us the smallest numbers. Okay, so that's 2,3-dimethyl cyclohexene. Okay. Now this one I gave you a hint. I said, be careful. So this is ethylene with 2 branches that are phenyl groups. So this is going to be 1,2-diphenyl. Now, what do I need to add to this? This is not quite correct the way it's written. What do I need to add? That's why I put careful down. Trans and cis. Which one? You're absolutely right. Which one is it though? Okay, think of, way to remember cis and trans. Cis, think of sisters, close together. Trans, transcontinental. They're opposite, like a plane. So is this cis or trans? Cis, right. No, because they're next to one another, as opposed to that. That would be the trans version. And then draw the structures given the name. So we have a heptene, 7 carbons long. One, two, three. 3 heptene. And on carbon number 2 is a phenyl group. And carbon number 6 is a bromo group. So start with the backbone and look at the functional group, then throw any branches in that need to be added. Okay, next one is we have a cyclopentanol. And doesn't matter where you start the OH group. So that's automatically carbon number 1. And then we have 2,3-dimethyl. Okay, cyclohexane, that's a 6-sided cyclic, and 1, 2, 3 methyl. And here's hexanol, 6 carbon alcohol, Carbon number 2, it's got the OH group. Carbons 3 and more have methyl groups. So that's naming. Okay, why does ethanol undergo hydrogen bonding? Okay, we just talked about ethanol a little while ago. So why does ethanol undergo hydrogen bonding? For hydrogen bonding to occur, what must be present? Hmm? Yeah, we have to have hydrogen bonded to fluorine, oxygen, or nitrogen. And does ethanol have any of those? Yeah, it's not like you were saying, OH. And why is this a strong or weak IMF? It's because the delta En is greater than 0.5. And it's greater than actually 1.5. It's pretty strong. Yes. Hydrogen bonding, anytime you have oxygen around, it's usually polar. So just kind of in general, oxygen or nitrogen, things get polar. Now there's exceptions to that, but in general, oxygen tends to make things polar. Okay. What's wrong with the following chemical name? Well, if we were to draw it out, okay, butane, 4 carbons long. And on carbon number 3 is ethyl. So what should the name be? Well, the longest backbone is 1, 2, 3, 4, 5. So it should be named pentane. Methyl pentane. Okay, everyone's favorite is reactions. Now I included the flow chart with the tests. So you're looking at the flow chart right now. So if you have your flow chart handy, take it out. Okay, so if you look on the bottom left, you'll see those conditions listed for alcohols. So what happens under those conditions? What do we form based on the flow chart? Which one? And you're right, by the way, but which is an ether because it's 140 and not 180. Okay, so we're going to form an ether. That means the OHs are going to be attached. So there's one. Now I'm going to flip it over. So that's where the ether is going to be constructed. Okay, if we change the conditions to 180, then what happened is we're going to pull off a water. So we need to find the water molecule on that first. Okay, so we have the OH parts there. Now we need an adjacent carbon with a hydrogen on it. Okay, so there's one here and there's one here. So that's one of the waters. And here's the other one here. So that means we're going to get a mix. So we take the yellow one first. That's where the double bond is going to be. Now, these are going to be hard to tell which is more stable, because they're both kind of the same kind of symmetry. Probably the one on the green one on the right is probably a little more stable than the one on the left. So this one I would probably say, don't worry about naming which one's more stable, because it's Markovnikov rule doesn't apply either. They're both 3 and 3 hydrogens. Okay, we have to name them now. Let's name these guys. Okay, this is going to be a cyclopentene. So is this one. And numbering, we're going to start here. Go 1, 2, 3. So it's going to be a three-methyl cyclopentene. And this is going to be a 2-methyl cyclopentene. We also have to name our reactant side. So this is going to be a cyclopentanol. And it's going to be 2-methyl cyclopentanol. That's a little more symmetrical than the other one. And so it would probably be a 55-45 split, something like that. Okay. All right, so here we have two alcohols. We need to make them. How do we make these two alcohols? Using your flow chart. Tell you what, let's do this differently here. Let's make them separately. So how will we make the first one? That's a primary alcohol. How could we make that? In the middle of your flow chart, you've got alcohols. And where do they come from? They come from alkenes, right? We put water across a double bond, we're going to generate an alcohol. So this is a 1, 2, 3, 4, 5. So it's a pentanol, and it's a primary pentanol because the OH is on the very end. Okay, so that means we need a 5 carbon okay, with a double bond on the end, so that when you put water across that, we end up with a mixture. So we need to name it. So it's going to be 1-pentene, 1-pentanol, 2-pentanol. Okay, so the next one down, we have a ketone. Ketones are made at the very bottom. And what do ketones need to be made? Oxidation of what? That's right. Oxidation of a secondary alcohol. All right. So the secondary alcohol are the ones in the middle. It's like ketones are in the middle. So we need to have a 1, 2, 3, 4, 5, again, a 5 carbon backbone. And the carbonyl group, the C double bonded O, is on carbon number 2. So that means the hydroxyl group needs to be on carbon number 2. And that's going to undergo oxidation. To generate that. Okay, for our unit 1, all you need to say it's a ketone, and this is going to be 2-pentanol. Okay, 1-butene, throw some acid in there. It's going to add across the double bond. Do you have a question? With the question?
What the previous reaction is?
Yeah, exactly. Yeah.
Okay.
Yeah. Or like I could put a question mark here and there too. It's just most of my later tests are usually gotten from older tests. So I grab from here, change it. So that's why sometimes the format is kind of weird. Organic tests are awful to make because they're all graphics. And I use Photoshop. I used to teach Photoshop up in Washington. So Photoshop and me are very comfortable, but I don't know what you do if you didn't have a graphic program. Okay, 1-butene and HCl. Okay, butene looks like this. And we're going to add HCl across that double bond. That means a mix. So you're going to get some HCl here and here. And this would be the more stable one. So this is going to be 1-butene. This would be 1-chlorobutane, 2-chlorobutane. Markovnikov, you've got 2 hydrogens, 3 hydrogens, so that's 5 hydrogens. And then 3 and 3 over here, so that's 6 hydrogens. So Markovnikov says the one on the right is more stable. Also, it's more symmetrical. Okay, 1-hexene with oxygen and platinum, some kind of a metal catalyst. So basically, you're going to have 1-hexene, and you're going to add hydrogen across that double bond. So we're going to end up with hexane. Okay, this is a 2-step process. First, we put the water across the double bond. Then we oxidize that product. So the first thing we need to do is figure out, so we're going to have that plus water, acid. So that water is going to add across that. So we're going to end up with that. Then we're going to oxidize it. Okay. Now, that OH is a secondary alcohol. Secondary alcohols get oxidized to ketones. So every time we have an OH, we're going to end up with a ketone. So this first cyclohexene, or excuse me, cyclohexene is going to be 3-methyl cyclohexene. And that's going to generate cyclohexanol. And we have 2-methyl and 3-methyl cyclohexanol. And these are ketones. You don't have to name those. That's unit 2 stuff. So that's a 2-step synthesis. In organic chemistry, that's very, very common to have 2, 3, 4 multi-step in a synthesis. All right, label the following. It's primary, secondary, tertiary alcohols. Okay, so this is going to be secondary, tertiary. Okay, when the OH is in the middle, it's secondary. When it's in the middle, but no hydrogens present, it's tertiary. And if it's on the end, it'll be primary, like ethanol. How many carbon atoms does 1-propyl-2-ethyl cyclopentane have? First thing is just draw the thing. So we have, it's a 5-carbon ring. Okay, so that's 5 carbons. Then we have a propyl group. So that's 3 carbons. And an ethyl group, 2 carbons. So 10 altogether. Why is the study of intermolecular forces important in biological systems? Mainly membranes. Membranes isolate the water reactions in our cells. Without having something that's nonpolar like a membrane, cellular membrane, all those reactions would just kind of mesh together and nothing specific could come of that. So membranes are the driving force for intermolecular forces in biological systems. Okay, so we have diethylbenzene. That would be ortho. Ortho means they're together. Para means they're opposing. And then meta is the middle. And then what's Markovnikov's rule? So if we applied it to this guy here, okay, 4-methyl-1-hexene. With some okay, so the water is going to add across carbon number 1 and 2. So there's going to be 1 here. What happens? Just went dark. Ah, what happened? Okay, then the other one I have no idea why my screen here went blank. Be here. Okay, so here we have 2 hydrogens, 3 hydrogens, 3 hydrogens, 3 hydrogens. So the one on the right has 6 hydrogens, one on the left has 5 hydrogens. So Markovnikov said the more terminal hydrogens, the more stable, hence that would be the preferred one. So what are the IMFs of the following molecules? Okay, right off the bat, they have London dispersion forces. Bam, every single one of them. Okay, that's got hydrogen bonding and dipole, dipole. That has LDF only. This has got, let me show you what that looks like. So it's dipropyl ether. Okay, so there's two COs. So 2 dipole, dipole. Okay, so of these 4, which has the highest boiling point? Right, the alcohol. What's next? Yep, the ether, because oxygen's present. And then between these two, it's kind of a push. So that could be 3-4 or 4-3. Give you credit for either one. No more tests. Okay, so do you guys think you could finish that in 2 hours? You haven't studied for it yet. um, so anyway, that's a typical test. And most students feel the hardest part of the reactions. So, all right, so that's it for today. I wanted to cover IMFs and then also, now on Thursday, I'd like to go over some worksheets with you. Just give you more practice in doing that. Yeah. I'm thinking next week. Yeah, the time when I have the tests, I like to kind of move them around a little bit so that they fit in with the lectures better. So I'm giving you more time in between tests on the first one than from those afterwards. If you've never had an organic test in your life, Unit 2 is biochemistry as well. I'm going to be covering carbohydrates in Unit 2, and those are big structures. Okay. So Tuesday lab folks, come up and grab your dry lab and you can get started on it. And as soon as I render this video, I'll be up. Actually, I'm going to come upstairs now. I'll put this away. So. Yeah,
Yeah.
I'm gonna, I'm following you when one problem is, sit at the table though, because the door's gonna be locked. But I'll be able to shortly though.